Welcome, students. In this video lecture, I come up with a question from a centroid. Here is the question: locate the centroid for the shape or area shown in figure. So for our workout, here we have the figure something like this. So this is a composite figure. Okay. So for this, we need to specify to find the centroid, nothing but x bar and y bar. We have to say the answer for x bar and y bar. Solution: the first step is just bring it into the coordinate. So I just going to draw a rough diagram. First I just going to take x and y, and from the left extreme I just going to have the coordinate arrangement. Okay, so this is the point just I going to keep here, right? So this is how the diagram will be, right? Something like this. And see, I have measurement here, so I just not going to represent any kind of measurement. If I need, I will be marking it down. Okay, fine. So here we have the circle, okay, which is a hole, and some of another composite material also there. Okay, so after just bringing it into the axis, xy axis, what we have to do is break down the component or into a simple component. Okay, break down the section, combined section, into a simple component. So what I going to do is, here if I see, just I have a right angle triangle. So for that, from this corner I just dropped a a line, so that I could able to see the first component as a right angle triangle. And then here if I put a line, straight line, here I could able to see the formation of rectangle, so which is second component I going to denote. And here comes, when I split it down, I got another one more the right angle triangle. Here's it's a circle, so I just going to make this as a fourth component. Okay, this is a fourth one, right? So four components are there, simple components. So by finding the self-centroid of these four components, we could able to plot the x bar and y bar. Let's begin with the first component. So first component, which is a right angle triangle. Right angle triangle. So that particular part, bring it into the coordinate. So then it will be easier, x and y. So this is how the exact arrangement is. What about the length? What about the length? Here it is given, which is 4 centimeter. 4 centimeter. What about the height of the object? Height of the object, entire height is, see, here to here, which is 16, and 16 plus 8 will be getting 24. Okay, we'll get 24, and plus 4, then this end to this end, which is given as again 4. So we get 28. We get 28 centimeter. Okay, the entire length of this is 28 centimeter. And then this self-centroid for this object we need to find, right? So if I represent, this is the C, this x1, we need to find it, and we need to find the y1. So this is O. First try to find out the x1. What about the formula for the right angle triangle? See, just we cannot take the formula because the direction or position of the right angle triangle is differ. Am I right? So basically we have four position when you come to the right angle triangle. So this is the basic position. Actually, this is how the basic position. So is it just like this? No, right? It is differ. So what we can do is, the simple one is x h divided by 3, sorry, breadth divided by t 3, and y is equal to h divided by 3. And if you see, the second quadrant is something like this, and third is something like this, and fourth is something like this. Can you able to see it? Yes. So what about the second one? Is it looking just like second one? Yes. This diagram is actually just like a second quadrant, right? So I said, when you are locating for the second, third and fourth quadrant, you must consider the x and y axis, whether it is directing towards the minus or positive. So this will be positive, this will be negative, since it is left side, am I right? So this is positive. Here comes, this is negative, right? This x axis, which is a positive one. Here x-axis is negative, so x-axis is negative in the sense, for the negative term we need to, for the negative axis we need to multiply by 2. So 2 into b divided by 3, the same formula, but what we are doing is, it's a trick. When you are having the negative axis, for that particular axis we need to multiply by 2. So here for the second quadrant, and y is a positive, right? X is negative and y is a positive. So for the positive one, as it is in the basic one, just you can write h divided by 3. So this is the formula we are going to use here, since this is just like a second quadrant. So here the formula will be, in order to specify the x1, 2b divided by 3. So that it will become 2 into b is 4 centimeter, b is 4 centimeter divided by 3, so that you will be getting 2.66 centimeter, 2.66 centimeter as x1. y1 formula is h divided by 3. So h divided by 3, h is 28, h is 28, 3, so that you will get the answer as 9.33 centimeter. Okay, what is next? x1 y1 is over, then it is area of first component a1. So a1, it's a right angle triangle. What is the area formula for right angle triangle? Triangle in the sense 1 by 2 into length into breadth, right? So 1 by 2 b which is 4 and h which is 28, right? So here the area will be 56 centimeter square, 56 centimeter square. Area as a unit is centimeter square. Okay, so first component over, the second component, which is a rectangle, which is a rectangle, so that particular thing we need to bring it into the coordinate. This is x, y, this is o. Where it is located, just we need to locate it. So from the y axis it is been far, right? Somewhat far from it. So from the y axis I just kept far from it. And what about the gap between the y axis and this particular side? Here see, the distance from this to particular this is 4 centimeter. So this distance is 4 centimeter. From the y axis it is with 4 centimeter. You must note it down. Okay, it is important part. And what about the length and width of this rectangle? Rectangle width is 10 centimeter. And what about the height of it? Already we have calculated when you done it for what rectangle, right angle triangle, right? So that particular measurement is 28 centimeter. which is also for this right angle triangle. So here the self-centroid, somewhere here it will be. So this would be x1, x2, and this particular thing will be y2. This is what we are going to identify. So x1. So x1, which is equal to, see, we just going to identify from O to this particular point C. Okay, this O to this particular point C in the x direction. So up to the component, what is the distance? Up to the component, what is the distance? Which is 4. So add 4 plus, now it's over. Then this to this is a self what centroid measurement. So for the rectangle, which is b divided by 2, length divided by 2. So it will be 4 plus b is 10 divided by 2. So we get 9. We get 9 centimeter. Have you got it? Always keep remember, only if you in this particular place, if you put b divided by 2 alone, then your answer will be wrong. Our thing is from O to this particular C distance we are going to find. So this gap must be measured first, and then plus its self-centroid formula must be added. Okay, always keep it in your mind. O to that particular distance. When you come to the y1, it is just from O, right? O to this particular distance. There is no gap between this component. So directly we can substitute the formula, which is for the rectangle is h divided by 2. So 28 divided by 2. What we get is 14 centimeter, right? Then it's a area A2. This is x2, this is y2, right? Don't commit mistake, x2, y2. This is the second component. And area 2, the rectangle, so length into breadth, so b into h. So here the b is 10 into 28. So we get 280 centimeter square A2. Have you got it? What is next? Move to the next component, third component, which is the same right angle triangle. Right angle triangle, and our goodness, it is just in the basic position, right? Basic position. But where it is located, some distance from y, right? Some distance from y. This is how it is being located. There is a gap. So we need to measure how it is, how far from the OY. How it is far from. By seeing the measurement 4 plus 10, I can say it is 14 centimeter ahead from OY. Okay, this need to be found. And what about the height of this right angle or width of the right angle triangle, which is already it is calculated. Total height is 28, here as well 28, here as well 28 centimeter. What about the length of the right angle triangle, which is given 4 centimeter, so 4 centimeter. Okay, now come to the calculation part. X3, Y3 and A3. X3, the distance from O to that particular centroid, right? If it is here, then this particular distance is X3 and this particular distance is Y3. So this distance we are going to found. So from this O2, the component distance is 14, that must be added plus 8 self-centroid. Self-centroid, it's a right angle triangle, so the formula is b divided by 3. So the formula will become 14 plus b is 4 divided by 3. What is the answer? Just calculate it, so that I hope you will get 15.33 centimeter. And y3, it is from O, right? The component is from O, so no issues, directly put the self-centroid formula. So here for the right angle triangle, it is h divided by 3, height is 28, so divided by 3 we get 9.33 centimeter. Okay, and next area of this right angle triangle, the component 3, area 3. So area, so right angle triangle is 1 by 2 half into length into breadth, b h, half b into h. So 1 by 2 b into h, b is a 4 and h is 28. So we get 56 centimeter square. 56 centimeter square. What about fourth one? Fourth component. What is the fourth component here? Which is a what? Which is a circle and which is a hole. Okay, which is hole. It's not a component. This is the exact component. Here the circle denotes it's a hole. So just note it down. It's a hole, and just plot it into the coordinate x, y, where it is located, somewhere here, right? So now just try to identify from OX how far it is. From OX, from this end to this end, the measurement is directly given, which is 16 centimeter. And next, identify how far from OY. Okay, how far from OY. So here, just see from this O, this is the point O. Am I right? This is the point O. From this to right angle is 4 centimeter. We need to find up to this. We need to find up to this. This distance actually we need to find. Where this is the distance which comes here. So see from this to this. So first 4 plus, and then see, look at this. From this to this particular center, we have the measurement which is 6. So what I going to do is, this particular distance is what? The radius of the circle. So diameter is given, which is 8 centimeter. The diameter which is given as 8 centimeter. So radius is r. So what I going to do is, radius is 4 centimeter. So this to this particular center of this circle is 6 centimeter. So I am going to put 6 minus 4. So this particular point to this center is 6 centimeter, and this is with the 4 centimeter. So from the 6 I just going to minus this 4, so that I will get this measurement. Okay, this measurement. So here 4 plus 6 minus 4, I just get how much? 6 centimeter. So it is with 6 centimeter, and its diameter is 8 centimeter. Okay, let it be. So now x1 we need to find. X1 in the sense this particular distance to center of it. It's a x4. So this particular distance to the center. So that gap is 6 plus self centroid measurement is d divided by 2. So 6 plus 8 divided by 2, I'll be getting 10 centimeter. Okay, for y4, here as well, measure the gap from OX to this particular, just 16 plus d divided by 2, the same formula for it. So 16 plus d is 8 divided by 2. So here I will get 20 centimeter. And what about the area? Area A4. What is the formula? Pi or square is for a circle. So pi in the sense 3.14 into radius, or radius in the sense half of it. So 4 the whole square. Radius is equal to how much? 4 centimeter. So that particular thing I have put. So here the answer we get 50.26 centimeter square. Okay. So now we have identified the self-centered and area for the first component, second, third and fourth component. What is next? The x bar and y bar, the centroid, x bar and y bar. So here x bar, centroid x bar is equal to a1 x1, that means sum of first moment of area about y axis. So here divided by total area, right? So here the component we have is 4 component and one is whole, the circle is whole. Okay, this is the removed section, it's not our part, this is our part, this particular region is removed, it's a whole, it's not included in the particular portion. So what I'm going to do, just see the formula, a1 x1 plus the second component a2 x2 plus a2 x a3 x3. Okay, a1 x1 plus a2 x2 plus a3 x3. I said it's a whole, circle is a whole, so I just going to minus, it's not our part, so I going to minus it from the total area. I just going to minus this so that I will get the centroid for it. So here I just going to minus a4 x4 divided by total area. So a1 plus a2 plus a3, the removed section must be minus a4. Have you got it? Don't commit mistake. It's not our part, it's a removed section or whole. So what we have to do is that particular must be minus from the total. So for that I have made the minus sign here. So here the formula will be a1, a1 is 56. Here the a1 is 56 into x1 which is 2.66 plus a2 we need to find, right? So a2, here it is, a2 280 into x2 which is 9 plus a3 is 56 plus a3 is 56 into 15.33 plus, here it is minus, so add minus sign, and then a4 which is 50.26 and minus into multiply into 10. Add all the areas, 56 plus 280 plus 58, only this a4 must be minus, that is 50.26. okay, so when you just do the calculation, the x bar you get 8.85 centimeter, the x bar will be 8.85 centimeter. This is the answer. Okay, and if you find the y bar, y bar in the sense sum of first moment of area about x axis. So here the formula will be a1 y1 plus a2 y2 plus a3 y3 minus a4 y4. We know it's a removed part, so it's a minus. So here a1 plus a2 plus a3 plus a3 minus a4. Don't commit mistake and just substitute all the things. a1 is 56 into y1 which is 9.33, okay, plus a2 here 280 into 14 plus 56 into y3 which is 9.33, okay, minus 50.26 into 20 divided by the same 56 plus 280 plus 56 minus 50 minus 26. Okay, If you do the calculation, y bar we get 11.58 centimeter. Y bar is 11.78 centimeter. So after completing x bar and y bar, just make the result. Okay, result. How will you plot the result? So this is how the diagram is, right? So this is the y-axis and this is the x-axis and this is O. So now 11.58 for y and x 8.85. So actually this right angle triangle is 4. So greater than this you can mark the y-axis. So here x-axis. So here I just going to plot the x distance. Okay, just I going to plot the x distance, x bar. Okay, and y which is which is 11.58. The bottom to this particular circle is 16. So in between that particular circle, the particular line should be. So here I just going to logical manner, I just going to mark like this. So this is the y bar. Answer is 11.58. Okay. So I hope you understood how to just identify the x bar and y bar, nothing but the centroid. If any components come, the first thing should be take it to the xy coordinate and just divide it into simple component and identify each and every self, centroid and areas, and afterwards then find the x bar and y bar. Okay, I hope you understood. Thank you so much.